flavor, American English, or flavor, British English, see spelling differences, is the sensory impression of food or other substances, and is determined primarily by the chemical senses of taste and smell. The trigeminal senses, which detect chemical irritants in the mouth and throat, as well as temperature and texture, are also important to the overall gestalt of flavor perception. The flavor of the food, as such, can be altered with natural or artificial flavorants which affect these senses. A flavorant is defined as a substance that gives another substance flavor, altering the characteristics of the solute, causing it to become sweet, sour, tangy, etc. 1. A flavor is a quality of something that affects the sense of taste. 2. Of the three chemical senses, smell is the main determinant of a food item's flavor. 5 basic tastes: sweet, sour, bitter, salty, and umami, savory, are universally recognized, although some cultures also include pungency. 3. Analia gustus, fattiness. 4. The number of food smells is unbounded. A food's flavor, therefore, can be easily altered by changing its smell while keeping its taste similar. This is exemplified in artificially flavored jellies, soft drinks, and candies, which, while made of bases with a similar taste, have dramatically different flavors due to the use of different scents or fragrances. The flavorings of commercially produced food products are typically created by flavorists. Although the terms flavoring and flavorant in common language denote the combined chemical sensations of taste and smell, the same terms are used in the fragrance and flavors industry to refer to edible chemicals and extracts that alter the flavor of food and food products through the sense of smell. Due to the high cost or unavailability of natural flavor extracts, most commercial flavorants are nature identical, which means that they are the chemical equivalent of natural flavors, but chemically synthesized rather than being extracted from source materials. Identification of components of natural foods, for example a raspberry, may be done using technology such as headspace techniques, so the flavorist can imitate the flavor by using a few of the same chemicals present. Contents: flavorants or flavorings, taste, color restrictions and regulations, regulations on natural flavoring, dietary restrictions, flavor creation determinations, scientific resources. See also references, external links. Flavorants or flavorings. Flavorings are focused on altering the flavors of natural food products such as meats and vegetables, or creating flavor for food products that do not have the desired flavors such as candies and other snacks. Most types of flavorings are focused on scent and taste. Few commercial products exist to stimulate the trigeminal senses, since these are sharp, astringent, and typically unpleasant flavors. 3 principal types of flavorings are used in foods, under definitions agreed in the EU and Australia. 5. Type description: natural flavoring substances. These flavoring substances are obtained from plant or animal raw materials, by physical, microbiological, or enzymatic processes. They can be either used in their natural state or processed for human consumption, but cannot contain any nature-identical or artificial flavoring substances. Nature-identical flavoring substances: these are obtained by synthesis or isolated through chemical processes, which are chemically and organoleptically identical to flavoring substances naturally present in products intended for human consumption. They cannot contain any artificial flavoring substances. Artificial flavoring substances: these are not identified in a natural product intended for human consumption, whether or not the product is processed. These are typically produced by fractional distillation and additional chemical manipulation of naturally sourced chemicals, crude oil, or coal tar. Although they are chemically different, in sensory characteristics they are the same as natural ones. Most artificial flavors are specific and often complex mixtures of singular naturally occurring flavor compounds combined together to either imitate or enhance a natural flavor. These mixtures are formulated by flavorists to give a food product a unique flavor and to maintain flavor consistency between different product batches or after recipe changes. The list of known flavoring agents includes thousands of molecular compounds, and the flavor chemist, flavorist, can often mix these together to produce many of the common flavors. Many flavorants consist of esters, which are often described as being sweet or fruity. 6. Chemical odor: diacetyl, acetyl propionyl, acetoin, buttery isoamyl acetate, banana benzaldehyde, bitter almond. cherry cinnamaldehyde cinnamon ethyl propionate fruity methyl anthronylate grape limonene orange ethyl decadenote parallyl hexanote pineapple ethyl maltol sugar, cotton candy.
Ethylvanillin vanilla.
Methyl salicylate wintergreen manzanite apple. The compounds used to produce artificial flavors are almost identical to those that occur naturally. It has been suggested that artificial flavors may be safer to consume than natural flavors due to the standards of purity and mixture consistency that are enforced either by the company or by law. 7. Natural flavors, in contrast, may contain impurities from their sources, while artificial flavors are typically more pure and are required to undergo more testing before being sold for consumption. 7. Flavors from food products are usually the result of a combination of natural flavors, which set up the basic smell profile of a food product, while artificial flavors modify the smell to accent it. 8. Unlike smelling, which occurs upon inhalation, the sensing of flavors in the mouth occurs in the exhalation phase of breathing and is perceived differently by an individual. In other words, the smell of food is different depending on whether one is smelling it before or after it has entered one's mouth. 9. Taste. While salt and sugar can technically be considered flavorants that enhance salty and sweet tastes, usually only compounds that enhance umami, as well as other secondary flavors, are considered and referred to as taste flavorants. Artificial sweeteners are also technically flavorants. 10. Umami or savory flavorants, more commonly called taste or flavor enhancers, are largely based on amino acids and nucleotides. These are typically used as sodium or calcium salts. 11. Umami flavorants recognized and approved by the European Union include 12. Acid salts. Description: glutamic acid salts. This amino acid, sodium salt, monosodium glutamate, message, is one of the most commonly used flavor enhancers in food processing. Mono and diglutamate salts are also commonly used. Glycine salts. Simple amino acid salts typically combined with glutamic acid as flavor enhancers. Guanylyc acid salts. Nucleotide salts typically combined with glutamic acid as flavor enhancers. Inosinic acid salts. Nucleotide salts created from the breakdown of AMP, due to high costs of production, typically combined with glutamic acid as flavor enhancers. 5. Ribonucleotide salts. Nucleotide salts typically combined with other amino acids and nucleotide salts as flavor enhancers. Certain organic and inorganic acids can be used to enhance sour tastes, but like salt and sugar, these are usually not considered and regulated as flavorants under law. Each acid imparts a slightly different sour or tart taste that alters the flavor of a food. Acid description: formulation pH. Acetic acid gives vinegar its sour taste and distinctive smell. C2H4O2 pH 3.91. 13. Ascorbic acid found in oranges and green peppers and gives a crisp, slightly sour taste, better known as vitamin C. C6H8O6 pH 3.59. 14. Citric acid found in citrus fruits and gives them their sour taste. C6H8O7 pH 3.24. 15. Fumaric acid found in bolete mushrooms, Icelandic moss and lichen, not found in fruits, used as a substitute for citric and tartaric acid. Enhances flavor and sourness. 16. C4H4O4 pH 3.19. 17. Lactic acid found in various milk or fermented products and give them a rich tartness. C3H6O3 pH 3.51. 18. Malic acid found in apples and gives them their sour tart taste. C4H6O5 pH 3.33. 19. Phosphoric acid used in some cola drinks to give an acidic taste. H3PO4 pH 3.06. 20. Tartaric acid found in grapes and wines and gives them a tart taste, also called racemic acid. C4H6O6 pH 3.18. 21. Color. The color of food can affect one's expectations of the flavor significantly. 22. In one study, adding more red color to a drink increased the perceived sweetness, with darker colored solutions being rated 2-10% better than lighter ones, though it had 1% less sucrose concentration. 23. Food manufacturers exploit this phenomenon. Different colors of Fruit Loops cereal and most brands of gummy bears often use the same flavorings. 24. 25. Restrictions and regulations. Regulations on natural flavoring. UK food law defines a natural flavor as a flavoring substance, or flavoring substances, which is, or are, obtained by physical, enzymatic, or microbiological processes from material of vegetable or animal origin, which material is either raw or has been subjected to a process normally used in preparing food for human consumption and to no process other than one normally so used. 26. The UK food industry also draws a distinction between a food being X-flavored, where it contains some amount of X as an ingredient, and X-flavor, where it has the taste of X but does not contain it. 27. The U.S. Code of Federal Regulations describes a natural flavorant as the essential oil, olea or resin, essence, or extractive, protein hydrolysate, distillate, or any product of roasting, heating, or enzymolysis, which contains the flavoring constituents derived from a spice, fruit, or fruit juice, vegetable or vegetable juice, edible yeast, herb, bark, bud, root, leaf, or any other edible portions of a plant, meat, seafood, poultry, eggs, dairy products, or fermentation products thereof, whose primary function in food is flavoring rather than nutritional. 28. The European Union's guidelines for natural flavorants are slightly different. 29. Certain artificial flavorants are given any number, which may be included on food labels. 30. Dietary restrictions. Food manufacturers are sometimes reluctant to inform consumers about the source and identity of flavor ingredients and whether they have been produced with the incorporation of substances such as animal byproducts. Citation needed. Some flavor ingredients, such as gelatin, are produced from animal products. Some, such as glycerin, can be derived from either animal or vegetable sources. And some extracts, such as vanilla, may contain alcohol. Many Jews, Jains, Hindus, and Muslims adhere to religious dietary laws, and vegans to personal convictions, which restrict the use of animal byproducts and/or alcohol in foods unless subject to oversight and inspection by their respective religious authority or moral beliefs. In many Western countries, some consumers rely on a Jewish kosher pareve certification mark to indicate that natural flavorings used in a food product are free of meat and dairy, although they can still contain fish. The Vegan Society's sunflower symbol, which is currently used by over 260 companies worldwide, can also be used to see which products do not use any animal ingredients, including flavorings and colorings. Citation needed. Similarly, persons with known sensitivities or allergies to food products are advised to avoid foods that contain generic natural flavors or to first determine the source of the flavoring before consuming the food. 31. Such flavors may be derived from a variety of source products that are themselves common allergens, such as dairy, soy, 32, sesame, 33, eggs, and nuts, 34. Flavor creation. Food and beverage companies may require flavors for new products, product line extensions, for example, low-fat versions of existing products, or changes in formula or processing for existing products. In 2011, about $10.6 billion were generated with the sale of flavors. The majority of the flavors used are consumed in processed and packaged food. 35. Most flavors represent a mixture of aroma compounds, the raw material that is produced by flavor companies. In rare cases, a single synthetic compound is used in pure form. Artificial vanilla flavors vanillin and ethyl vanillin are a notable exception, as well as the artificial strawberry flavor, ethylmethylphenylglycidate. The ubiquitous green apple aroma is based on hexyl acetate. 36. The flavor creation is done by a specially trained scientist called a flavorist, whose job combines scientific knowledge of the chemical palette with creativity to develop new and distinctive flavors. The flavor creation begins when the flavorist receives a brief from the client. In the brief, the clients attempt to communicate exactly what type of flavor is sought, in what application it will be used, and any special requirements, e.g., it must be all natural. The communication barrier can be quite difficult to overcome since most people are not experienced at describing flavors. The flavorist uses his or her knowledge of the available chemical ingredients to create a formula and compound it on an electronic balance. The flavor is then submitted to the client for testing. Several iterations, with feedback from the client, may be needed before the right flavor is found. Citation needed. Additional work may also be done by the flavor company. Citation needed. For example, the flavor company may conduct sensory taste tests to test consumer acceptance of a flavor before it is sent to the client or to further investigate the sensory space. The flavor company may also employ application specialists who work to ensure the flavor will work in the application for which it is intended. This may require special flavor delivery technologies that are used to protect the flavor during processing or cooking so that the flavor is only released when eaten by the end consumer. Citation needed. Determination. Few standards are available or being prepared for sensory analysis of flavors. 37. In chemical analysis of flavors, solid phase extraction, solid phase microextraction, and headspace gas chromatography are applied to extract and separate the flavor compounds in the sample. The determination is typically done by various mass spectrometric techniques. 38. A flavor lexicon can aid the development of objective language for food.